So let's start with this, okay? And for now, we are just going to talk a bit about sets. So sets is just basically groupings of things together, okay? But we do need to know a little bit about sets as we start with Venn diagrams. But as we go, you'll see that you actually know sets already because it's just groupings of things. Okay, so in a hat, there are cards numbered from 1 to 10. So the sample space, and last week we spoke a lot about sample space, we can write that sample space as a set. So in mathematics, there's a special way of doing it. We're going to call these cards that are numbered from 1 to 10, we're going to call that grouping S. And that's what you do when you have a set. You give it a name, like an S or an A or a B or an X or a Y. You'll see now we're going to do that a lot when we work with sets. So this particular one, we're going to call the set. And we're going to put it together inside a curly bracket. Now you guys get to practice your curly brackets. I really like making curly brackets. Muskako, what about you? What's your favorite bracket? A round bracket, a curly bracket, or a block bracket?
I like the curly one, but I can only ever draw the left one nicely. When I get to the right one on the other side, it comes out so funny and squiggly. So my OCD kicked in.
So what are these cards? They are cards numbered from 1 to 10. So in our set, we are going to have those cards numbered from 1 to 10, and we're just going to list them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we close our set. We're saying all these numbers go together. They're a set of numbers. And we put a curly bracket at the end. Please separate your numbers using a semicolon, because if we just do it with a comma, it starts to look like decimal numbers. Okay, so when you list your set, all the numbers that are in your set, use a semicolon. Okay, so there's our set of 10 numbers, and we've written it now nicely into a set notation with our curly brackets. So when you hear set notation, think of that, the curly bracket stuff. Okay, now there are 2 events. So we put the cards in this hat and we shake it, and now we're going to start drawing from it. And the first event that we have is drawing a factor of 6. So now remember, our cards just go from 1 to 10. So which numbers from 1 to 10 in our set are factors of 6? Who can put them in the chat for me? Pop it in the chat, or if you know. Remember, factors are numbers that divide evenly into 6. Watobians are listing nicely, but there's one that you are forgetting. An important factor of 6 that we are leaving out is 1. So 1, 2, 3, and 6. Those are all factors of 6. And we are going to put it into another set together here. And that is 1, semicolon, 2, semicolon, 3, and 6. And close it off again. Now, as you are making notes at home, this is what you should be doing, okay? Writing the factors of 6. Okay, next one, the factors of 9. Also, that's a different set, or that is 2 events. 1, 3, and 9. 1, 3, 9. I think that one's easy. 1, 3, and 9. And let's do that. Let's make it a colorful day with lots of different colors. 1 can go into 9, 3 can go into 9, and 9 can go into 9. Okay, and as we list them, we put them in the curly brackets to say that the numbers between 1 to 10, the factors of 6 are 1, 2, 3, and 6. The factors of 9 are 1, 3, and 9, and we give them names, X and Y. That's their names. Okay, so which elements? Remember, elements are the different things that are in the set. which elements are in both X and in Y? Which ones are in both X and in Y? Okay, that's easy to see, right? That's 1 and 1, 2's not, 3 and 3. Okay, so let's list those, and we can say that the ones that are in both X and Y are 1 and 3. Now, in probability, when we work with stuff like this, where we have two things that are the same, so we've got the the numbers that are factors of 6 and the numbers that are factors of 9, and the things that are the same, that we call, this is the new word you need to learn today, if you don't know it already, we call that the intersection. So the intersection occurs in both of those events, so in X and in Y, and the intersection is 1 and 3. Okay, Ms. Coco, could you help Milani, please, just with the elements? Okay, this is called the intersection. Okay, Noma Swazi, I think Ms. Coco needs to just help you with your mic or with your audio as well. Okay, but Ms. Coco, how's my audio? Can you hear me clearly?
I hear you loud and clear, ma'am.
Okay, so this is called the intersection. And the symbol for intersection or and is this thing here that looks like a bit like an N without the leg part, with its leg chopped off, if I can call it that. Okay, so we've got notation so far, we've got brackets, curly brackets, and now we've got this thing where we are going to say the intersection, or the things that I have in X and in Y. That word is important, and, but I'm not going to write and, I can use this symbol for it. The definition of intersection. Okay, I'll do it right now, in a minute. But I think it's, the definition is not so important. Just for now, just listen carefully and understand the whole idea that intersection looks at the elements that are in both of the two events. So if I look at X and Y, the things that I have in X that I also have in Y is 1 and 3. So that is what is called the intersection. Okay, just the things that they have in common, that's in both X and in Y. Okay. Now, a way for you to remember this symbol is, think of it as a magnet, and the magnet is the thing that connects A and B. So if I want to say what is the intersection of X and Y, I write X intersection Y equal, and now I'm going to list the things that they have in common, which was the 1 and the 3 that you guys all rightly pointed out. So that's a way for us to write. So intersection and things that they have in common, the elements that are in both sets, those, all of those ideas go together. All right. Let's just see in the chat, put a thumbs up if you're happy with with everything so far. Let's just check in. Let me know how you are doing with this. Thumbs up or a thumbs down, if not so much. If you are putting a thumbs down, then please ask a question. It's always easier to explain something when there is a well-formulated question indicating to me exactly what it is that you are wondering about. Okay, lots of thumbs up. Well done, everybody. If you do have a question, or if you've put a thumbs down, pop a question over to Ms. Coco, or just pop a question into the chat so that we know what it is that you are wondering about. Okay. Now the next one, so here's our sets. We have X and Y, and I'm just going to copy it down from over here so that we can see it clearly. where we are working. So we said X and Y are these two things that can happen, the two events. Let's just do this. For some reason, it doesn't want to put it there. Let's go like this. Nope. Okay. Okay, we'll just leave it, I think, and rewrite it. Okay, so we said our X was from our sample space. If we drew the factors of 6, X was 1, 2, 3, and 6. And then our Y was the factors of 9. So that's 1, 3, and 9. Now, which elements, so listen carefully, which elements are in Y, in X, or in both? Think about that. Pop your answer in the chat if you think you know. Which elements are in X, Y, or in both? It won't always be 2. It could be more than 2, Lisa. It could be more than 2. Yes, there's a George. Go for it. Ask your question.
Hi, ma'am. I'm sorry.
Hi.
I don't understand where you got the values for the numbers for 1, 2, 3, and 6, and then for Y 1, 3, and 9. I can't understand where you got it from.
It was here drawing a factor of 6. That was the 1, 2, 3, and 6. From our cards, remember, we are drawing cards numbered from 1 to 10 from the hat. So which of those will have a factor of 6? That's 1, 2, 3, and 6 will be factors of 6. And if you're drawing a 9, it will be 1, 3, and 9. That's where I got it from.
Thank you.
So read carefully, guys. The question was, which elements are in Y, or in X, or in both? This word is important, not and. Okay, we just did and. We said, there we go, Fence. Fence is saying 1, 2, 3, 6, and 9. That's right. Which elements are in Y, or in X, or in both? And that really is everything that's in X or in Y. So I include everything from X and Y in it. So we can say it's 1, 2, 3, 6, and 9. Okay, so or, don't confuse or with and. And means it's in this one and it's in this one. So there's an overlap between the two. But or means I take from X or from Y or from both. And that then actually includes everything from X and everything from Y. And that is why this is called the union. The union contains all the elements of both events. And we write union with that symbol over there. It looks like this. Okay, so you're learning really cool maths today, because this is quite, I mean, Miss Coco, you doing at varsity using all this stuff, aren't you?
I am. I'm crying on the varsity side. I like this part. This is the nice, easy stuff.
Yeah, so you're learning, really taking big steps today. Great, taking big steps. Okay, so how are we going to remember this funny line, this upside down? I thought you can say that it's like, for your boat, you need an oar, and a boat is like that shape, and an oar is that paddle that you paddle your boat with. So I thought that you could row your boat using your oar. Okay, so we've got and, which is the magnet. And I think everyone must go and, or, and with the magnet, or for the boat. Okay, right. How are we doing, Watobians? Pop a thumbs up in the chat so that we know you understand the difference between the and the or. Good stuff. Nice. And again, if you're not so sure, pop a question in the chat or pop one over to Miss Coco. She, like I say, she is just doing varsity maths and all sorts of cool stuff. So she'll definitely be able to explain. Okay. Right. Now let's see if we can nail this. Okay. Tokolo, here's another one. You're going to see now. Let's try it again. More cards. Cards are numbered 1 to 8 and placed in a box. Now it's your turn, Watobians. Pop it in the chat. Use set notation to list the sample space S. Okay, so set notation. I want to see those curly brackets. We're going to start with S equal. I'll help you if you can't make curly brackets on your phone or on your computer. I'll make curly brackets. You tell me what must go into the curly brackets. Nice, Keith. Our cards go from 1 to 8, okay? So just modify yours so that it goes up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Nice. We are catching on to our... There's so many, like when you working with probability, it's always cards, dice, spinners, all of that stuff. 7 and 8. Close the curly. There we go. Now use set notation for the event O of drawing an odd number. Oh, I've drawn an odd number. How am I going to write that? For those of you who are doing it in the chat and you are doing your curly brackets, well done. Just don't forget to name your set, okay? Your set has a name. Here we've got the event O. Pop it in the chat, please. The event O of drawing an odd number from our cards. If you draw an odd number, which ones are you going to draw? There we go. Riachile's got it. And Fence's got it. Okay, just remember, when we do it actually, we must make curly brackets, not round brackets. And we must say what the set is called. The set is called O. And in that set, I'm going to put 1, 3, all the odd numbers, 1, 3, 5, and 7. Okay, nice. Next, let's do the set notation for the event E of drawing an even number. I don't know what that is, Mokoko Bali. I don't think that is set notation. Hey, Ms. Coco. Nice, Riachile again. E, curly brackets, 2, 4, 6, and 8. Close curly brackets. Right. Now, what does this mean in plain English? The next question, question 4. I want to see if anyone can translate this for us into plain English. Write the event, and then O, and then that symbol E, in set notation. What is the question asking for? Who listened from the previous question? Oh, you are very right, Inam. Thank you. Tennis also. But do we have a... Oh, no, sorry, Inam, this is a new question.
No,
we
it's
only...
10. Yeah, it only
Yeah,
goes up
we
to
only
8.
have cards. For the intersection, nice, Lashandre, Eunice, O union E, yeah. It's not union, though, be careful. What did we say it was? sorry, it is union. It's when you are going with your or in your boat. That's it. Odd or even. So if it's odd or even in set notation, how are we going to write that? You can pop your answer in the chat. The events of O or of E. It's odd or it's even. Okay, so pop your answer in the chat. Which elements are going to be odd or even? We've got odd, even. If we do odd union, that's it. Nice, Asanda, very nice. And you even, I wonder if that's a U or if she found the symbol. Nice one. And Diswa also got it. Fense got it. If it's odd or even, then it's the odd numbers or the even numbers. We put them all together, and that gives us the union of the two when with our boat and with our oar. Okay, nice. So I'll write it here for us nicely in the proper set notation. So we're going to write that, and it really is one. I can actually copy this. Can be that. There we go. Okay. And then the last one, write the event O, and then there's intersection E in set notation. So what are we looking for now? We said that the previous question, we used odd or even. So that was the word or. Now we're looking for the intersection. Nice, Latondre and Andiswa. O and E. So we are going to look for the two sets O and E where there's overlap. Is there overlap between the two? There is no intersection. Very nice. No. No intersection. Because a number can't be odd and even. You're never going to get that. Yes, Enrique. Yes, Enrique, you can ask your question. Okay, Enrique, sorry, we have to move on. Remember, guys, if you have a question, then be quick about it to ask. Okay, now if you really want to be fancy, guys, then you can write your empty set like this, because it doesn't happen. Okay, there's no intersection between the two. Okay.
Yeah, I wonder if you know the other symbol for
I think
empty.
let's maybe just stick to the two symbols for today, Miss Coco.
Okay.
Yeah.
All right. No, agreed.
Okay, Latina, don't stress. We're going to move on now to drawing some Venn diagrams. So don't stress. Just follow along. It's all good. Okay, just follow along. And if you do have any questions, just pop it over to Miss Coco. Okay, so I'm speaking to an iPhone. iPhone, you can quickly ask your question.
Ma'am?
Yeah.
Can I ask, ma'am, from the previous examples that you gave us, ma'am, could you please re-explain question 4?
Sorry, the what?
Ma'am, from the examples that you gave us, can you please re-explain question 4, number 4?
Okay, so that when we are talking about the union, that is, we use the word or, so a number that is odd or even or both. So that if you look at this at O, which was an odd number, that was 1, 3, 5, and 7, and an even number is 2, 4, 6, and 8. And if you're looking at odd or even or both, then you're really looking at the union of the two, both of those things, everything that's odd and everything that's even together. Okay. Okay, guys, so I'm going to give you just 30 seconds to read this question quickly. As always, pop your emoji glasses in the chat to tell me that you are done reading. Just read the parts, don't draw anything yet. Just read the different, the set and the events, the sample space and the events. Okay, Nyasha, you have a question? Go for it. Everyone else, just keep reading.
Afternoon, ma'am.
Hello.
How are you?
I'm fine, thanks, and you?
I'm well, thank you, ma'am. Regarding to the probability of writing the events, could we also write it in fractions? Because, ma'am, I do AP mathematics, so we already did probability. So how we were taught is you could also write it in fractions.
Yeah, we haven't even done probability today yet. We're just writing sets and Venn diagrams, okay? But yeah, probability is written as a fraction. But we haven't done any probability today yet.
Thank you.
Okay. So Sipho, last question.
Good evening, ma'am.
Hello.
So ma'am, I wanted to ask about the sample space. So at school, we've already started with Venn diagrams. Now for the sample space, we usually write it as S equals to, let's say, the total numbers inside. Now I wanted to ask, is it still okay if we write it like that?
Do you just the total numbers inside? I'm not sure what you mean. Do you just say how many numbers there are? How many, like the total of the elements?
Yes, ma'am. Like, let's say maybe there's 9 numbers, so that S equals to 9.
Okay, yeah. So we're gonna get to that where you can also do the actual frequencies instead of the listing the actual elements. But today we're just working on listing the elements.
Okay, ma'am. Thank you, ma'am.
Okay. Okay, right. So let's draw a Venn diagram to show each of the following. We're going to start off doing the sample space. Now, our sample space is basically just a rectangle. So here's our sample space. And we're going to put all our elements of the sample space in it, which is the numbers 2 to 9. And you can just put them like that: 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that literally suggests that this is our sample space. Okay, now event P is in the sample space. So our event P is 3, 6, and 9. So what we're going to do is we're going to draw our sample space again. But within that sample space, we have this event P. And for an event, we make a circle. And we indicate in that circle all its elements. So 3, 6, and 9 are in that little grouping together. But everything else is still in the sample space. So we still have to include it. The 2, the 5, not the 6, but the 8, and the 4, and the 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's it. Okay. Now do your own one quickly for question C, where you have to do the same for events P and Q in the sample space. I'm just moving this down. Unfortunately, you won't be able to put that in the chat for me, but you can check that you have done yours correctly. So we've got events P. Now, before you draw for Q, you have to check, do they have anything in common? Well, yes, they do. They have 3 and 3 in common, and 6 and 6. So what did we say when there's that overlap? Our circle for P and our circle for Q are going to have to show that there's that overlap, so they are going to cut. And where they cut, we put the things that they both share, the things that they have in common, 3 and 3 and 6. But we just put it once. We don't put more than 1 3. We just put a 3 and a 6. The other elements of Q is just the 2 and then the 9 for P. Oh, and don't forget, you need to label them so that you know which is which. So that's P, that's Q. And we still put all the other things that are in the sample space, even though it isn't part of event P or event Q, we still list those things. So the 2 is in Q, the 4 is still in the sample space, the 5 is still there, so is the 7 and the 8. And then keep checking that you've got the right total. There should be 8 numbers. Yes, there's 8. Okay, just give me a thumbs up in the chat if everyone is happy so far with our Venn diagram drawing. It's very quiet out there. Okay, now last representation that we are going to make is P and R in the same sample space. So here we have our P, or our sample space rather. Now R is 4 and 8. Nothing in common, so we don't have to worry about any overlap between R and P. So we're just going to draw P over here. P is the numbers 3, 9, and 6. And R is over here, no overlap, 4 and 8. Sure, we will. And outside of those 2 events are the remaining numbers 2, 5, 7. And I think that's everything. Yeah. Okie dokes. Right. Last question for tonight. I'm going to let you work on your own quickly so that you can draw these Venn diagrams. And we're also going to start looking a bit at probability from Venn diagrams. You can start the question, everybody. You've got about 3 minutes while I take a few questions. And Carlo, let's hear from you. Tantalo, you can ask your question.
Ma'am, can I ask that? Ma'am,
Yep.
are the numbers that aren't overlapping inside the Venn diagram circles called the mutually exclusives?
Yes, you can call them mutually exclusive, yeah. If there's no
Isn't
overlap.
Ma'am, isn't there an easier term for them?
For mutually exclusive?
Yes, ma'am.
Not that I know. No, those are the maths words we use for them. Ms. Coco, I don't think there's anything else, another way to say it.
No, and normally mutually exclusive is when we're doing probability and looking at sets. They're just sets in the sample, like the elements in the sample space and not in the subset. But that's also very complicated.
Yeah, we're going to do mutually exclusive probably on Thursday and then into next week as well. But it just means that there's no intersection. And being in the one means you can't be in the other. Like you can't be at home and at school at the same time. Sorry, guys, I've scrolled and while I was talking. Sorry, Warren. So yeah, so you can't be in two places at the same time, for instance. That's basically what mutually exclusive is. Okay, Asanda was next. And then I hope everyone's ready with their answers. Yeah, Asanda?
Hi. So, like maybe if you get a question that says, like you must put the set, what is the question again? Set notation, sample space, like P and Q. Must it be like in the correct order that the question was given, or can it be switched around maybe?
Sorry, just ask your question again. I'm not sure I understand correctly.
Like the sample space, like you given P and Q, and then you write it in your sample space. Must like P be first, or like you can put it in any way? Just like the
No,
answer
you
is
can put
correct.
it, yeah, if you do your Venn diagram, it's fine. You can put it anyway.
Okay, thank you.
Okay. And last question, Nyasha.
Ma'am, also with mutually exclusive, it means that there's no intersection happening in the diagram, meaning there are two diagrams and they have their own numbers and they're all equal to 1. That's mutually exclusive. If
Yes,
I've answered a question.
That's right. Thank you. Okay, so for those of you who haven't done mutually exclusive yet, don't worry, we will get there. So there's our sample space. And then the elements of S, drawing a card that is a factor of 12. Pop that in the chat for me, Watobians. Let's see the sample space or the elements of set A, drawing a card that is a factor of 12. Hello, anybody? Factors of 12, the numbers that can divide. Oh, there's Andiswa. Oh, good gracious. Maybe my internet is slow. Okay, good stuff.
You've
So the
got to give
elements...
them time to type, ma'am. I feel like they just need a second to type.
No, they must be quick. No time. 1, 2, 3, 4, 6, and 12. That's our set A. Okay, and then list the elements of set B, drawing a card that is a multiple of 4. So B, a card that is a multiple of 4. Remember, only from here can we choose. So that is 4, 8, and 12. And then represent A, B, and S by means of a Venn diagram. Okay, so you can't post your Venn diagrams. I wish you could, but we're going to make our sample space, which is our rectangle. Now we have to check, is there intersection? There is intersection indeed. There's the 4 and the 4 and the 12 and the 12. So when I draw my two circles that represent A and B, I need to show that. So there's A and there's B. So where the overlap is, that is 4 and 12. Sorry, it's really small. 4 and 12 but it's 1, 2, 3, and 6 for A. And for B, we are doing 4 and 8. And then the remainder of the numbers just fall outside those two sets. So it's 5, 10, 7, 9, and 11. What about 1? 1 is there with A. I did pop it in there. Thanks. Okay, and then what is the probability of being in A, or what is the probability of A happening? So we count 1, 2, 3, 4, 5, 6. There are 6 elements in A out of the 12. So the chance of getting an element from A is 1/2. We do count, I see Fancy says 4/12. We do count the intersection as well, because that is still part of A. It is, we still factor that in. And then what is the probability of B? So we've got 1, 2, 3 elements in B, so 3 out of 12, and that's 1/4. And then what is the probability of not A? So that little dash sign means not. Some of you might not have seen it before, but it just means what is the probability of not getting A? So if you're not getting A, then you're getting B and all the other numbers. Okay, so you can't include anything from A. So that would be 8, 5, 10, 7, 11, and 9. So that's 1, 2, 3, 4, 5, 6 out of 12. And that is 1/2. Okay, that's it for me for this evening. I'm going to hand over to Miss Coco, and then I have to dash right away to the other class. But thanks so much, everybody. And we'll carry on again on Thursday with more Venn diagrams. So you have some time to think about it. Okay.